Students, welcome to Narayana. This is Srinivas, lecturer in physics. Today let us discuss 30th January 2023 mains paper, session 1 paper. Okay, first let us see the first question. A bullet of mass 10 grams is moving with horizontal velocity v, hits the ball placed on the tower of height 20 meter from ground. After collision, the bullet hits the ground 120 meter from the ball and hits the ground 30 meter from the foot of the tower. Find the velocity v in meter per second. So here, let this is a tower of height 20 meters. A ball is placed on the top of the tower and this is ground. A bullet of mass 10 gram strikes the ball placed on the top of the tower with velocity v. Then after collision, ball falls at a distance of 30 meter from the foot of the tower and bullet falls at a distance of 120 meter from the top of the tower, from the foot of the tower. Then what is velocity of the bullet? We have to find velocity of the bullet. Okay, here what is the, first let us find what is the time taken by the bullet or ball to reach the ground. So that time taken t equal to root of 2h by g. Time taken t equal to root 2h by g. That is root 2 into height of the tower is 20 by g 10. So this is 2 seconds. So here the time taken by the ball or time taken the bullet is 2 seconds. So both take same time to reach the ground. Okay, here let us find velocities of the bullet and ball after collision. After collision, let v1 be the velocity of ball and v2 be the velocity of bullet. Then from conservation of linear momentum, 10 into 10 power minus 3, this is given in grams, into velocity of the bullet. This is total linear momentum of the bullet before collision. That is equal to momentum of the ball. Momentum of the ball is mass of the ball 200 grams into velocity 200 into 10 power minus 3, that is mass of the ball is given in grams, that is into velocity v1 after collision plus mass of the bullet 10 grams, that is 10 into 10 power minus 3 into v2. v2 be the velocity of bullet after collision. That is here 10v equal to 200 into what is the velocity of ball here. Velocity of the ball here, it has travelled 30 meter in time 2 seconds. So velocity of the ball is in horizontal direction. What is the displacement covered by the ball? 30 meters. So velocity of the ball in the horizontal direction is that horizontal displacement 30 by time taken plus 10 into what is velocity of bullet after collision? Horizontal velocity, that is what is the horizontal displacement covered? 120 meters in 2 seconds. That is 120 by 2. So here we can cancel 1 0 on both sides. Then this is V equal to, this is 100 into 300 plus this is 660. This is 360 meters per second. So this is the velocity of the bullet before hitting the ball. So the ball hits the, the bullet hits the ball with velocity 360 meter per second. Okay, let's move to next question. So for a polytropic process, Pt square equal to constant, where P is pressure and T is temperature. Find the coefficient of volume expansion. Okay, here given equation is Pt square equal to constant. Okay, we know PV equal to nRT. We know PV equal to nRT. Then P equal to nRT by V. Let us substitute that here. That is nRT by V into T square. That is equal to constant. That is T cube V square, T cube V, or T cube equal to some constant K. You take nR this side. So then constant by some constant and take this V to the right hand side. Then T cube equal to K into V. Okay, K is some constant. That is this constant by nR. nR is a constant. So T cube equal to K into V. This is the equation. Then let us differentiate this on both sides. That is 3 T square dt equal to K into dV. So this is K into dV. Next, here we have to find coefficient of volume expansion of the gas. For that, what is coefficient of volume expansion of the gas? Gamma equal to dV by V dt. This is coefficient of volume expansion of the gas. Fractional change in volume for unit change of temperature. This is coefficient of volume expansion of the gas. That is, so we can substitute that dV here. dV equal to 3T square dt by, or simply what is dV by dt here? dV by dt equal to 3T square by K. dV by dt is 3T square by K. So this is 1 by V into dV by dt. This is 1 by V into dV by dt. 1 by, what is V here? V is T cube by K. This is T cube by K into dV by dt. dV by dt value is 3T square by K. 3T square by K. So here we can cancel this K. and this t square with 1 t, then this is 3 by t. So that is gamma equal to 3 by t. So gamma equal to 3 by t. This is that is answer is third option for this question. Okay, next let us move to next question. Two isolated solid conducting spheres of radii r and 2r having same surface charge density initially. Now the spheres are connected by thin conducting wire and the surface charge density on the two spheres are sigma and sigma dash respectively. Then find sigma dash by sigma. Here these are two solid conducting spheres of radii r and of radii r and 2r. So when these are connected by a conducting wire, charge flows from high potential sphere to low potential sphere so that their potentials become equal. So finally Q1 be the charge on this and Q2 be the charge on this. Their total charge is redistributed in such a way that their potentials are equal. That is V1 equal to V2. V1 is 1 by 4 pi epsilon naught Q1 by R. That is the 1 by 4 pi epsilon naught Q2 by 2R. So ratio of the charges Q1 by Q2 is 1:2. So Q1 by Q2 ratio of the charges finally Q1 by Q2 is 1:2. So in the ratio of their resistors, radii. So this is the ratio of the charges finally. Then what is the surface charge density sigma? Sigma equal to Q by area, that is 4 pi r square for any sphere. That is sigma proportional to Q by, that is sigma is proportional to Q by r square. So sigma by sigma dash equal to Q1 by, this is Q1 by Q2 into R2 by R1 whole square. That is Q1 by Q2 is 1:2 and R2 by R1 is 2:1 whole square. This is nothing but 2 by 1. This is 4 by 2, that is 2 by 1. Then what is sigma dash by sigma? This is 1 by 2. So this is the answer. Sigma dash by sigma is 1 by 2. du plus dw, as du is 0, dq equal to dw. So that is work done by the gas is equal to the amount of heat absorbed. So from this work done by the gas is, if the work done by the gas is positive if heat is positive. Work done by the gas is positive if heat is positive. This is here heat is absorbed by the gas means dq is positive. Heat is supplied to the gas, heat is positive. Heat is withdrawn from the gas, heat is negative. So here dq positive, so dw is positive. So that implies dw is positive. Okay, so S1 is wrong. So work done by the gas is positive, S2 correct. Next, internal energy is constant, S3 also correct. Statement 3 also correct. But S4 internal energy increases, that is wrong. S5 internal energy decreases, that is also wrong. So what are correct statements here? Work done by the gas is positive, internal energy is constant. So statement 2 and 3 are correct. So S2 and S3 are correct. So option 3 is correct. Okay, next let us move to the next question. In a hydrogen atom, velocity of electron in 7th orbit is 0.0 308 into 10 power 6 meter per second. Find velocity of electron in the third orbit. Okay, velocity of electron in any orbit is proportional to z by n. We know this from derivation. Here z is the same. In the same atom, we are comparing velocities of electron in 7th orbit and 3rd orbit. That is V1 by V2 equal to V1 by V2. Say V1 is the velocity in the 7th orbit, V2 is the velocity in the 3rd orbit. That is equal to, as z is constant, V proportional to 1 by n, that is n2 by n1. That is V1 is velocity in the 7th orbit, that is V1. By V2 we have to find, that is equal to, n2 here is the 3rd orbit, so n equal to 3 and n1 is 7. Then from that V2 equal to 7 by 3 V1. This is 7 by 3 into V1 is 0.308 into 10 power 6. So nearly this is 0.1, 3 0.1s. So 0.1 into 7, that is, so 0.719, we can get this. So option 1 is correct. So this is 0.719. Next, let us move to the next question. A point object is placed at 40 centimeter in front of a converging mirror and its real image is obtained at 120 centimeter. Scale used to measure distances has 20 divisions in 1 centimeter. Error in focal length is 1 by k centimeter. Find k. Okay, a point object is placed at 40 centimeter in front of a converging mirror, that is a concave mirror. Then from this equation 1 by v plus 1 by u equal to 1 by f. So we have to get the error in the focal length, in the measurement of focal length. First let us find the focal length. Here focal length, here a point object placed at 40 centimeter in front of converging mirror and its real image is real. So object distance negative and image distance also negative, because if this is the mirror, this is the principal axis, if object is here, its real image is given, so both are negative. So 1 by minus, what is the distance, image distance given, 120 centimeter, minus 120 centimeter plus 1 by object is placed at 40 centimeter, minus 40, that is equal to 1 by f. Then this is taking minus sign common and 120 LCM. This is 1 plus 3. This is 1 by f. This is minus of. So f equal to 30 centimeters with negative sign. That is minus 30 centimeters. This is the focal length of this converging mirror. Okay. Then how to get the error in the measurement of focal length? For that, minus 1 by v square plus minus 1 by u square So let us differentiate this equation first. Let us differentiate this equation. So minus 1 by v square into dv plus minus 1 by u square into du, that is equal to minus 1 by f square minus 1 by f square into df. So here we have to find df. So all that negative signs get cancelled on both sides. This dv is error in the scale, that is 1 by 20. So let us write all these in centimeters. So this is 1 by, what is V? V is 120 square into dV is 1 by 20. dV is 1 by 20 because there are 20 divisions in 1 centimeter. So one division length is 1 by 20. That is the least count. So 1 by 20. So least count of the instrument is the error plus 1 by u square, 1 by 40 square into du 1 by 20. This is equal to 1 by 30 square into df. So let us take 1 by 20 into 40 square, 1 by 20 into 40 square common in this, 1 by 20 into 40 square. Here 40 into 3, this is 1 by 9 remains here. So 120 you can write 40 into 3, that is 40 is taken common, 40 square. So 3 square 1 by, that is 9 plus 1, this is equal to 1 by 900 into df. Then this is so if you see this 1 by 20 into 1600, this is This is 1600 into 10 by 9 here. This is 10 by 9. That is equal to df by 900. So here we can cancel this 0 and this 9 and 2 zeros this side, and this is df is 1 by 32 centimeters. So K is 32. So the value of K is 32. Next, let us move to the next question. So a capacitor of capacitance 900 microfarad is charged to voltage 100 volt. Now it is connected with identical uncharged capacitor. Find out heat produced in joules. Okay, heat produced H equal to half C1 C2 by C1 plus C2 into V1 minus V2 whole square, where V1 V2 are the potentials to which the capacitors are charged. C1 C2 are the capacities. So this H equal to heat produced H equal to, so capacitor of capacity 900 microfarad charged to 100 volt. Now it is connected with identical uncharged capacitor. So uncharged capacitor means potential of the second capacitor 0. So that is half C into C. Both are identical capacitors here. So capacity of first capacitor is C and second capacitor also C, that is 2C into V square. Here this is 0, V2, that is V minus 0 whole square, that is nothing but V square we can write as V2 is 0. That is this is here 2C, 1C you can cancel. This is half, that is 1 by 4 into C V square. that is 1 by 4, C 900 microfarads, that is into 10 power minus 6 into V square is 100 square, that is 10 power 4. So these two zeros and 10 power 4, this cancels with 10 power minus 6. This is 9 by 4, which is 2.25 joules. So rounded off to nearest integer, it becomes 2. Next, let us move to the next question. A particle with x equal to a sin omega t is performing SHM with time period t. Its potential energy is maximum for first time at t equal to capital T by beta. The value of beta is. Okay, let this be the mean position of the particle executing SHM. T with the time period. And displacement is equation is given as a sin omega t. So it has no initial phase. It has no initial phase. That is, if you put t equal to 0, at t equal to 0, the particle is at mean position. At t equal to 0, particle is at mean position. At mean position, potential energy is minimum. Then, what is the time taken for this particle to move to the extreme position? T by 4. We know that this time is T by 4. Time taken by the particle to move from mean to extreme position is T by 4. So when it moves to extreme position, potential energy becomes maximum. So the minimum time is T by 4. So after a minimum time of T by 4, potential energy becomes maximum. So the answer is T equal to T by 4. So that is beta equal to 4. Okay, let us see next question. Find the potential in volt of battery so that rod is in equilibrium. Given B equal to 10 power minus 3 Tesla, resistance R equal to 5 ohm. Okay, here we have to find the potential of the battery. So for this rod to be in equilibrium, net force on the rod should be 0. For that, here okay, next let us move to the next question. Okay, in this question, find the potential in volt of battery so that rod is in equilibrium. Given B is 10 power minus 3 Tesla, resistance 5 ohm. Okay, this is the rod. M is the mass of the rod. That is, mass of the rod is given as M equal to 1 gram. That is 10 power minus 3 kg. For this rod to be in equilibrium, its weight is to be balanced by magnetic force applied by the magnetic field. And the magnetic field is applying force upwards. So here weight of the rod is acting vertically down. M is the mass of the rod. This is mass of the rod is 1 gram. That is 10 power minus 3 kg. Mass of the rod. So for this rod to be in equilibrium, its weight is to be balanced by force applied by the magnetic field. Force applied by the magnetic field on this current carrying conductor is BIL here, because this length and field are mutually perpendicular. Field is inwards and length and field are mutually perpendicular. Then theta becomes 90 and this becomes BIL, that is force. So for this to be in equilibrium, BIL, that should be equal to weight. B into I is V by R. V is potential difference of the battery by resistance. Here resistance, total resistance of the circuit is given as 5. It is not given the resistance of the rod. So we have to neglect the resistance of the rod. So total resistance in the circuit is R only into L, that is equal to mg. Then what is V? So here V equal to this, V equal to mg R by B into L, mg R by BL. So V equal to, what is mass of the rod? 1 gram, that is 10 power minus 3. G you can take 10. Resistance is given as 5 by B is given as 10 power minus 3 into length is given as 10 centimeters. Length is 10 centimeter means 0.1 meter. That is this 10 power minus 3 goes, and this when it comes to the numerator it becomes 10. So this is 500 volts. So this is the battery potential difference. Okay, next let us move to the next question. The heat passing through cross section of a conductor varies with time t as qt equal to alpha t minus beta t square plus gamma t cube. Find the maximum heat current through the conductor. Heat current through the conductor is dq by dt, that is equal to alpha minus 2 beta t plus 3 gamma t square. Next, what is the maximum heat current through the conductor? For this heat current to be maximum, this differentiation of this function, that is rate of change of this should be 0. That is, say let this be I, heat current I. This I di by dt, that should be 0 when it is maximum. That implies, what is di by dt here? Alpha is a constant, so 0 differentiation of that. That is minus 2 beta plus differentiation of this is 6 gamma t, and this should be 0. From this 2 beta equal to 6 gamma t, from that this is t equal to beta by 3 gamma, then substitute this t here in this equation. Then I maximum equal to alpha minus 2 beta into t is beta by 3 gamma plus 3 gamma into t square, beta square by 9 gamma square. Then this is so 2 beta square by 3 gamma, this is, so 1 gamma you can cancel here. This is 3 3's. So this is plus beta square by 3 gamma. This is minus 2 beta square by 3 gamma. Then this is alpha minus beta square by 3 gamma. This is beta square by 3 gamma. So alpha minus beta square by 3 gamma. So answer is second option. Next question. In a region, the value of gravitational field is G equal to minus K by x square, and K is given 6 joule per kg centimeter. If potential at x equal to 2 centimeter is 10 joule per kg, find potential at x equal to 3 centimeter. Okay, here gravitational field G is given as minus k by x square, minus k by x square, and k is given as 6 joule per kg centimeter. If potential at x equal to 2 centimeter is 10 joule, find potential at x equal to 3. Okay. So potential difference, we know this equation dV equal to minus G bar dot dr bar, and this potential difference between 2 points, if these are at a small separation, this is the potential difference. So V2 minus V1, if 2 points, potential difference between 2 points is integral minus G bar dot dr bar. This is R1 to R2. That is potential at x equal to, we are moving from x equal to 2 to x equal to 3 centimeters. And we have to find potential at x equal to 3. At x equal to 3, potential be V2 and V1 we know that is 10 k joule per kg, V1 minus 10, that is equal to, here you see this, if you see this equation, minus G bar dot dr bar. So here G is in the negative direction of x-axis and we are moving from x equal to 2 to x equal to 3. It is, we are moving in the positive direction. Then minus angle between G and dr bar is 180 degrees. That is minus G into dx. We write in terms of x because G is given in the function of x. So minus G dx cos 180, that is, this minus sign with cos 180 gets cancelled, that is G into dx, that is G into dx, and that you can write it here, that is minus G bar dot dr bar value you can write simply G dx. This is R1 to R2, that is 2 to 3. And this G is magnitude of G only we have to consider. Already we considered the sign, that is G direction also we considered because this negative sign is giving the direction of G. So just write magnitude, that is G by, that is G is K by x square, K by x square into dx integral, that is 2 to 3, k by x square into dx, that is so V2 minus V1 is 10, that is equal to k into integration of this is minus 1 by x, that is x power minus 2 plus 1 by minus 2 plus 1, and this is 2 to 3. Then this is V2 minus 10 equal to k into, k is 6 joule per kg, it is in centimeters, so that's why we are substituting that x in centimeters, and this is substituting, so to remove this negative sign we can change the we can interchange the limits, that is k is 6 into 1 by 2 minus 1 by 3, we can write it here, that is equal to 6 into 3 minus 2 1 by 6, this is 1 by 6, so this is 1. So V minus 10 is 1, finally V2 minus 10 is 1 we got, then V2 is 11, 10 plus 1, this is joule per kg, so 11 joule per kg, this is V2. Next, two identical mass particles P and Q are attached by two different strings from same point. If P is released from horizontal position and Q is in vertical position, all the collisions are elastic. Find velocity of Q just after collision. So this particle is released from the horizontal position and this is in the vertical position. So what is the velocity with which the particle P hits the second particle Q? That is V equal to root 2 GH, where H is the vertical height through which it is falling. Then what is that value? That is 2 into G 10 into height 20 centimeters, that is 0.2. So this point can be cancelled with 10. This is 2 meter per second. This is the velocity with which the particle Q is colliding with the particle Q. Particle P is colliding with particle Q with velocity 2 meter per second. And as these two are having same mass and the collision is elastic, P comes to rest and Q takes the velocity of the first body. That is, this Q is taking the velocity of this body. This P is hitting this with velocity 2 meter per second. So P comes to rest and Q takes the velocity. That is, Q moves with velocity 2 meter per second. So velocity of Q after collision is 2 meter per second. Next, let us move to the next question. An inductor and resistor are connected to AC battery source such that XL equal to R and power factor is P1. If capacitor is connected in series to this circuit such that XL equal to XC and power factor is P2, then ratio of P1 by P2. So we know that power factor is nothing but cos phi. This is nothing but R by Z. Z is the impedance, R is the resistance. Here an inductor and resistor are connected in the first case such that XL equal to R. When XL equal to R, what is Z here? Z in this case is, Z in the first case, Z equal to root of R square plus XL square. This is R square plus R square under root. This is root 2 R. This is root 2 R. Root 2 R. Then what is cos phi? Power factor P1 is nothing but cos phi. That is nothing but R by Z. Z is root 2 R. This is 1 by root 2. This is P1, power factor. Next, in the second case, if capacitor is connected in series to this circuit such that XL equal to XC. Now this is an LCR series circuit. Then in this case, Z impedance Z becomes root of XL minus XC whole square, XL minus XC whole square plus R square. Then given that XL equal to XC here, so this becomes 0, then Z is R. Now in this case, power factor P2 equal to cos phi, which is R by Z. Cos phi, that is R by Z. In this case, R by Z in this case is R only. So this is 1. So what is P1 by P2 then? P1 by P2 equal to 1 by root 2. So X is 2 here, X equal to 2. Okay, next let us move to the next question. In amplitude modulated wave, maximum amplitude is 120 volt and minimum amplitude 80 volt. Then find amplitude of carrier and modulating wave. So maximum amplitude 120 is AC plus AM, where AC is amplitude of carrier, AM amplitude of modulating signal. And minimum amplitude is 80 given, that is AC minus AM. Then adding these two, 200 equal to 2 AC. So these two get cancelled. Then AC is 100. AC is 100 volt. And what about then AM? AM becomes 20 volt because AM plus AC is 120. So 120 volts, option 1. Next question. Surface tension of liquid A and B is T and 2T respectively. So surface tensions of two liquids A and B are T and 2T respectively. Density of liquid A and B are rho and 2 rho respectively. Height raised by liquid A is 5 centimeter in capillary tube. Then find height raised by liquid B in the same capillary tube. So H equal to 2T cos theta by R rho G. We know this formula. Height to which the liquid rises in the capillary tube is H equal to 2T cos theta by R rho G. That is, here assume contact angle for both liquids is same. So contact angle same. So cos theta same. 2 is a constant. Capillary tube radius is the same. Density of liquid A and B, rho and 2 rho. Height raised by liquid is 5 cm in capillary tube. Find the height raised by liquid in the same capillary tube. So radius same. G also same. Then H proportional to T by rho. So H1 by H2 equal to T1 by T2. T1 by T2 into rho 2 by rho 1. So H1 is 5. H2 we have to find. T1 is T and T2 is 2T. Rho 2 is 2 rho and rho 1 is rho. Then rho you can cancel TT, then this is 1, that is H2 is 5 centimeter. Here also this is 5. Okay, let us move to the next question. The relation between bulk modulus K and modulus of rigidity and Poisson's ratio sigma is. So from the derivation, sigma equal to 3K minus 2 eta by 6K plus 2 eta. So this is the relation between Poisson's ratio, bulk modulus and rigidity modulus. Next, let us move to the next question. So in this question, find the value of I. Okay, here let us redraw that circuit. This is 2 volt battery. The current I is coming here like this. And this is a branch here. This is 1 ohm. Here 1 ohm resistor is there. And this is another 1 ohm resistor here. This is 1 ohm. And here there is a 1 ohm resistor. and here there is a battery of 5 volt, and here there is a 2 ohm resistor here, 2 ohm resistor, and here there is 2 ohm resistor here. This is a 2 ohm resistor, and this is connected like this. Okay, then to find this current, let us take the potential here be 0 volt, and potential difference of this battery is 2 volt, so here potential is 2 volt, so we can take here potential 2 volt, here 0 volt, so here also 0 volt at this junction, here also 0 volt potential, and here potential be some x at this junction, and potential here be some y. So y be the potential at this point. Then see here, at any point in a circuit, the algebraic sum of currents meeting at any junction is 0. From that, x minus 0 by 1 is the current in this branch. X minus 0 by 1 plus current in this branch is x minus 2 by this potential is x volt. So here 2 volt, x minus 2 by resistance of this is 1 ohm plus here potential is y, then potential at this point it is y minus 5. This is y minus 5. Here potential is y minus 5 because here potential is 5 volt. Potential difference is 5. So this is connected to negative terminal here. So this potential should be less than this potential. So if potential here is y, it should be y minus 5. Then what is the current through this? X minus this potential y minus 5, x minus y minus 5 by resistance of this is 1 ohm, that is equal to 0. This is one equation, that is x plus x minus 2 that is x plus x minus 2 plus x minus y plus 5 equal to 0. That is this is 3x plus 3, this is 3x plus 3 equal to y. This is equation 1, 3x plus 3 equal to y. Next, let us see the current across this junction, that is here at this junction y minus 0 by 2, here also because variables are there, so one more equation we need, y minus 0 by 2 plus what is current through this branch? Current through this branch is y minus 5 minus x by 1, y minus 5 minus x by 1. This is current through this branch. So we are taking this has higher potential than this, that is y minus 0 by 2. So this current y minus 5 minus x by 1 plus y minus 2 by 2. This is plus y minus 2 by 2. This is y minus 2 by 2 equal to 0. Now this is after taking LCM, y plus 2y minus 10 minus 2x plus y minus 2 equal to 0. Then this is 4y. This is 4y minus 2x. 4y minus 2x. 3y plus y. 4y minus 2x equal to 12. That implies y minus 2 equal to y minus 2x equal to 2y minus x equal to, sorry, this is 2y minus x equal to 6. Solving these two equations, so this is let us multiply this with 3, then this is 6y minus 3x equal to 18, and this is 3x plus 3 equal to, or this is, you can write 3x minus y equal to minus 3. This is 3x minus y equal to minus 3, we can write 3x minus y equal to minus 3. Adding this 3x gets cancelled, that is 5y equal to 15. So that means y equal to 3. If y equal to 3, then x becomes 0. That implies x equal to 0 here. That implies x equal to 0. Now, so after getting x equal to 0 and y equal to 3, so this implies y equal to 3 and x equal to 0 from this. Okay, so this potential y is 3 and x equal to 0. So this potential is 0. So no current is flowing through this branch, as these two are at same potential. No current flowing through this branch. Then this current flowing towards this terminal I, that should be equal to I here. Same current I that is coming like this, and it is splitting here, and no current through this branch. So all that current is passing through this. So what is current through this branch? What is current through this branch? Here we know potential here, 3 minus 0 by 2. So that current is simply I equal to 3 minus 0 by 2, which is 1.5 amperes. This is the current. Okay, next let us move to the next question. So if the graph between momentum and time is shown below, find the region of maximum and minimum force given T3 minus T2 is less than T1. T3 minus T2, this interval is less than T1 given. So here momentum time graph, this is. Find the region of maximum and minimum force. Force is the rate of change of momentum, that is dP by dt, so now, which is nothing but slope of this PT graph. If slope is more, then force is more. See here where slope is maximum, here if you see this from this graph, this is having the least slope, and we have to find out of these two which is having more slope in this region and in this region. Given that here this T3 minus T2 is less than T1, so clearly in this region, as this interval is small, slope is this by this amount. So automatically here this amount is more than this, slope is this amount by this amount. So that is, this amount is less than this, so clearly it has more slope here. So magnitude of force is here more, magnitude of force. So in this C region, maximum force F maximum is in the region C and minimum force is in this region B. F minimum is in the region B. So maximum force is in the region C and in the region B least slope, so least rate of change of momentum, hence force is least. So C and B. So answer 4. Next, in the expression, if the expression of electric field of wave can be written as E equal to A by x square j plus B by y cube j, find unit of A and B. See here, E equal to A by x square I cap plus B by y square j cap plus B by y square j cap. So this is not y square, this is y cube given. Plus B by y cube j cap. So from the principle of homogeneity of dimensions, dimension of each term in that equation on the right hand side should have the same dimensions as E. So E equal to A by x square. Dimensions of E and A by x square dimensions should be the same. So A dimensions should be equal to E into x square dimensions. Then E is Newton per coulomb and this is a meter square. E is a Newton per coulomb and this is x square is meter square. So A units are like this. A units are Newton per coulomb meter square. And similarly E equal to B by y cube. So that is B equal to E into y cube. E into y cube. Y is also distance. X distance, y and y is distance. This is Newton per coulomb. This is meter cube. So Newton per coulomb meter cube. So option 2 is correct. Next question. So in this circuit, find out the output waveform for input A and B. Okay, see, when two input terminals of this NAND gate, this is a NAND gate and this is NAND gate, this is also a NAND gate. When two input terminals of this NAND gate are connected, that is becoming a NOT gate. This is also a NOT gate. Now, here suppose if let us check for the input values, what are the output values? Let us check. See, in A is maximum, input A is maximum, B also maximum up to time t1. So A you can take logical value 1, 1, 1. So they become 0 and 0 here. For 0 and 0 inputs, if that is AND gate, it should be 0 output, but it is an NAND gate, so output is the inverse of AND gate. So this 1, 1 is becoming 0, 0 here. This 0, 0 should become 0 if it is AND gate, but it is NAND gate, so it is 1. So for 1, 1 it is 1. That is maximum, maximum, here also maximum. So if you see options, here maximum, here also maximum in 3 options. So we can eliminate 3, this option. Next for T1, T2 interval, let us see. For the next T1, T2 interval, A is minimum, B is maximum. A minimum means that is 0 logical value, this is 1. So 0 becomes 1 and 1 becomes 0. So 1, 0 here, 1, 0, for 1, 0, the output is 0 if that is a AND gate, but this is NAND gate. So for 1 0 it should be 1. So output is maximum. Maximum means maximum continues here also, but here minimum. So you can eliminate this also. Now in these two we have to check. Okay, next between T2 and T3, this is 0, this is 0. A 0, B also 0. Okay, 0 0, that becomes 1 1 here. For 1 1 inputs, if it is AND gate, it should be 1, but it is NAND gate, so it should be 0, so it should be minimum. So in the next T2 and T3 we are getting minimum. So here this is minimum. So up to here both are same. Next let us see the T3 T4. In this 1 1 both are maximum here. If both are maximum, we got already maximum here. So it should be maximum, but here it is given minimum. So answer is 1. Correct option is this. So option 1 is the correct option. Okay, next let us move to the next question. Okay, let us see the next question. A point source of light of power P equal 20 milliwatt is placed at the center of a hemispherical surface of radius 10 centimeter. The inner surface of hemisphere is perfectly reflecting. Find the force on the hemisphere due to light falling on it. Okay, this is that hemispherical surface. A point source of light is placed at center. So let us find the force acting on that hemispherical surface due to light falling on it. Here light falls on the surface perpendicularly at any point. So it gets reflected in the opposite direction. Then to find the force, let us consider a strip. Here let this makes a small angle d theta. This is theta, this is d theta. So on this strip let us find force, and then by integrating we can get the total force on the different strips. So here the light photons striking this in this direction get reflected in this direction and they apply force, say dF like this. Here also dF. If this is theta, this is also theta. Here also this is theta. Then component of that dF cos theta in this direction. Here also on any element dF cos theta on that strip, and dF sin theta of this and dF sin theta of this, these get cancelled. This is dF sin theta. So this is getting cancelled with this. So each element is experiencing a net downward force in this direction. So what is that total force? F equal to integral dF cos theta. So what is the dF first? Force acting. So you have to find that. For that, first what is the intensity in this region? Here general formula for intensity is the rate of flow of energy through unit area. So I is dE by dt into 1 by A, we can write like this. Now as the photons carry some momentum from Einstein's mass energy equation relation, dE equal to dm into c square. If dm, where dm is the mass of that photon, d is the energy of that photon. So this is a dmc into c, we can write. dmc is nothing but momentum. This is nothing but momentum, P into C. So momentum of the photon P equal to dE by C. This is the momentum of photon carrying energy dE. Okay, when this photon strikes and gets reflected in the opposite direction, what is the change in momentum? dP is 2 dE by C. Then what is the force acting on this? dF equal to dP by dt, rate of change of linear momentum, that is equal to 2 dE by C by dt. So this is 2 by C into dE by dt, and this dE by dt, what you can write, 2 by C into dE by dt is IA, where A is the area of the strip, that is 2 by C into I into dA. In place of A we write dA because that is small area of the strip. Then what is total force acting? F equal to integral dF cos theta, that is nothing but integral 2I by C into dA cos theta. This is 2I by C into 2I by C into integral dA cos theta is nothing but effective area in the downward direction, in this direction, effective area in this direction, because dA, you take area of this like this, dA cos theta will be the effective area of the strip in this direction. So integral dA cos theta is total effective area, that is nothing but pi r square. So F equal to 2I by C into effective area in this direction is nothing but pi r square. Integral dA cos theta is nothing but pi r square. So what is I here? 2 by C into I is power by area, power by 4 pi r square. Here the power of the source is falling on the area of this sphere, that is 4 pi r square. So in this region intensity power by 4 pi r square into this is pi r square. So this pi r square we can cancel. This is P by 2C finally. Then force F equal to P is power given 10 milliwatt, 20 milliwatt, 20 into 10 power minus 3 pi, 2 into C 3 into 10 power 8. Then this is 10 into, this is 10 by 3 into 10 power, if it comes to the numerator, minus 11 Newton. This is the answer for this question. Next, let us move to another question. Coil A of radius 10 cm has NA number of turns and IA current flowing through it. Coil B has radius 20 cm and has NB number of turns. IB is current flowing through it. If magnetic dipole moment of both coils is same, then so there are two coils carrying currents. This is the NA number of turns and current through this is IA, and this is another coil carrying number of turns NB, current through this is IB. So magnetic moment is NIA. So here M1 equal to given M2, that is NA IA into area pi into r square, pi into 10 square, this is in centimeters. Next NB into IB into pi into, this is radius 20 centimeters, second one 20 square. So this is 20 whole square. So pi you can cancel. This is 4, that is NA IA equal to NB IB into 4. This is 100, this is 400, so 4 times. So answer is this, fourth option.